Today we'll continue our discussion on linked list. Whatever we have seen in the past two lectures, that we'll try to now understand how it will be implemented. So as we have discussed in the earlier lecture, linked list is a linear data structure which have nodes in it, and every node have a data and a pointer field in that. All these nodes are stored at scattered location in the memory. Only thing we need to take care is we need to have the address of first address of that element available with the previous element, and the current element is going to store the address of next element. Likewise, element to element we can progress in accessing the entire uh, linked list. So in the last lecture, we have seen how the structure will be defined, what all you need to implement a linked list. That's what we discussed. We discussed that we need the knowledge of structure, we need the knowledge of uh, structure pointers and how to access the data using structure variables and structure pointers, and importantly, dynamic memory allocation. Because this is a dynamic data structure where every time an element arrives to be inserted in the linked list, we need to create or allocate a space for that node, and then only link it with the existing linked list. Okay, so that space can be created randomly anywhere in the memory, and that is just linked with the linked list. So in the yesterday's lecture, we have seen how the linked list and its nodes are created one by one, and uh, every last node is going to have a null pointer in that, because it is not going to point anywhere. It doesn't have a next node available with it. And only thing we need to maintain here is the address of first node, which will be called as a head node, and that head node will be guiding us to travel the entire linked list. So we need to keep track of these pointers. So ultimately, insertion and deletion in linked list is based on pointers. uh, Playing with pointers will be an important thing in this. So when we talk about linked list, there are different operations which we are going to perform in that. Mainly the operations are creation of a linked list. So there will be a bunch of elements which will be arriving. We will accept them one by one, and we'll insert them in the linked list. So it will be a creation of linked list. Then we may insert some nodes into that. Those insertions will be either inserting it at the end, or inserting at the beginning, or inserting in between two nodes at any position in the linked list. So the insertions will be at any point in the linked list. That's why we are considering this as a dynamic data structure, because unlike arrays, we can insert the element in linked list at any position. In array, it is not possible for us to insert an element. Practical, it is not practical. It is possible to insert, but at that time we'll have to shift all the elements downwards. We'll have to change the positions of all elements, make a space for that, and then only you can insert. But here it is not the case. You can insert it anywhere. Like we have we can see this here. If I am having a node to be inserted at this position, at the third position, let us say, it is again simply playing with pointers. We don't have to shift all the things, but we'll have to create a, let us say that we are trying to implement element 72, which is created at location number 600. So what simply we'll have to do is, if I want to insert it in between 25 and 4, it, what we'll have to do is we'll have to change at will accommodate. Discard this link and we'll create. Okay. So now the list will be read as 13, 25, 72, 4, and 53. So it is very easy for us to insert any element in between the linked list also, right? So that's why it is becoming a dynamic one. So insertion can be at the end, can be at the beginning also, and can be in between two nodes. Similarly, deletion will also be, you may delete the last node, you may delete the first node, or you may delete the node somewhere in between the linked list. So insertion, deletion are the two important operations, but all types of insertion and deletions are handled separately. That is, insert at beginning, insert at last, or insert in between will have their own separate constructs. Similarly, deletion will also be handled separately. And most importantly, we are going to traverse this linked list. Traversing the linked list from first list to first element to last element is also one of the important operation which we perform. Because why we are maintaining a linked list? To store the data. So most of the time we are going to search for the data in this case. So we'll have to traverse the entire linked list. And for traversing purpose only, we need to keep track of the first node. Only first node will be known, and from the first node we can get the second, then third, and then fourth, and so on. So this is the way we are going to handle a linked list. So in today's discussion, we'll see the first operation, that is how we can create a linked list. As I said, every when you try to create a linked list, let us say that these are the elements which are coming into picture. In yesterday's example, we have seen if they are coming in picture, these are to be inserted in a linked list. Then one by one we'll have to create a node for every element. So node for 13 will be created, which will be the first node. Then the second node will be created, whose address will be given to the first node. Then third node will be created, whose address will be given to the second node, and so on. So this way we are going to construct a linked list. And what we are doing, every time we are creating a new node and pasting it at the end of the list. So that is the way we can create a linked list. That's what we are going to see in uh, today's program. So of course, the first part we'll have to do is we'll have to define a structure. We'll have to define a structure. So this structure is a node structure, uh, which will have two portions in it, that is a data field and uh, the pointer field. Okay, so this is going to construct a node in this way, which will have two parts in it. One is the data part, another is the next part or link part or a pointer to the next node part. Okay, so this way you can have these two things. Fine. And then if you want the node to be created, every time you are going to create a variable for that struct node. Okay, so this way we are going to do it. So what we need now, how many variables we need for structure, for creation of a linked list? We need a node which will be the first node. So a head node will be there, we are going to maintain. We will have other pointer which will create a new node, and we need a third pointer which will point to the last node always, because from that last node we are going to proceed. So we may be needing three pointers, so these can be declared in this way. So we have three pointers. One will be the node pointer, which will point to the last node in the list, because after last node we need to append the new node. So time being it will be null. We need a head node or a pointer to the structure, which is called as head, which will store the address of that structure. So which will initially be null, and a new node which we create every time, and we'll have to store that, we'll try to store the data. Okay, so this will be your requirements. This will be your requirements. Now let us say that the first node is coming into picture. When first node is coming into picture, what we are going to do, we are going to call the malloc function to reserve the amount of memory required for that structure somewhere in the memory. Okay, so let us say that a new node will be created which will be allocated with a memory which is required by that thing. So it will have a data field, it will have a next field, and let us name it as P. Okay, so this node will be created. I don't know whether it is a first node or last node or the node in between, but as soon as the data is coming, we'll have to create a node. Now we'll have to check whether it is a first node or not. So the node is created. P is equal to malloc size of struct node. Okay, so malloc reserves this particular size, reserves this particular size, and is initialized to P. We need not to typecast it, as we discussed in the earlier lecture. We need not to typecast it because P is already a structure pointer. Okay, so now this purpose is done. This statement is performing this purpose. Okay, somewhere in the memory, let us say that at location number 200, P is stored. P is stored. Okay, now we'll have to scan the element which I want to store. So it will be scanf %d. We are expecting integer data. So %d p dot data. P is a pointer variable. That's why we are using the arrow operator. We are using the arrow operator. So let us say that we have inserted 10 over here. Any random value you can insert. For example, for illustration, I am taking it as 10. So with this statement, we have written data is equal to 10. We have inserted data is equal to 10. Okay, now what next? What will be its position, or where we are supposed to uh, insert? So we are inserting it at the end. That's why it is a creation of list. No, so we are sure that we are going to just append it at the end. So this will be made as null. The field will be made as null. Now we need to put it in the list. So there are two options. Either it can be the first element, right? Either it can be the first element or it can be the last element to be inserted, right? There are two options only. So if it is the first element, it will become the head node, and if it is the last element, it is going to become the current node. These two things only, or these two situations only, we need to handle. So what you are going to do now? In this case it is a first element. In this case it is a first element. So how I can judge it is a first element? I can judge it is a first element if head is still is equal to null. If head is null, then the node which is coming into picture is the first element, and if head is not null, then definitely it is not the first element. Okay, so in this situation, at this particular moment, head is null. We have initialized head as null. Okay, null means is not pointing anywhere right now. That means the node which is coming into picture, node which is named as P right now, containing data 10, is the first node. So we are going to initialize head or point head to that node. Am I right? So I hope you are understanding this. Head. So what will be the value of head? What will the value it is going to store? It's 200. Okay, head will be equal to 200 because that is the P node we are going to store. So that's the condition which we are checking. If head is equal to null, then it will be the first node. Initialize head. Okay, initialize head as P, and we need not to have head dot data or head dot null. We are just using head pointer as the starting address of that linked list. Okay, if you want to access it, we will rename it as some current node or something like that, and we'll access it. So it's not head will be just a pointer which will tell us how to begin. Fine. Now second thing, second possibility is Let us say that now a second node is coming into picture. We'll take that scenario. So right now, till this, it is okay. We have created a node, then we have scanned its data, and we have initialized its data field, link field to null, because that will be the last node which will be appended, and last node in the linked list will have pointer field as null or next field as null. And now then we checked whether head is equal to null or not. Yes, in this case head was null, and hence head is initialized to that node address. So head is now become 200, and at 200 we have p located. We have p located. Okay, so what is p? P is the new node which is created. Every time we are going to use pointer p for that purpose. Okay, for that purpose. So let us, what we can do is, we can maintain one more pointer, that is node. As I said earlier, node is going to point to the last node always, because we come whenever we get a node, we are going to append it after it. So we'll keep track of the last node. So right now in this case, node will also be pointing to p, head will also be pointing to p, and p is also pointing to p. Okay, now all these are at 200. Next case, let us say that a new data has arrived. New data has arrived. We are going to what we are going to do next, we are again allocate. So now p will be pointing here. Okay, p will be pointing here. We have already stored this address, so by node, so there is no need to maintain two pointers for the same purpose or same node. So a new node will be created called as p. The same possibility I am taking out. Okay, so in this case we are taking we are saying that head is not equal to null. So now next, so allocation is done. This is a data field for it. Again, this is the next field for it, and let us say that it is created at location number 300. Location number 300. Now scan its data. Let us say that let us assume it is 20. So at 300 location, P is created and its data is 20, and its next field will be null, because we are going to paste it at the end of list. Okay, may it be the first or last, first or any other node, but it will be at the end of list. Now after this, we are going to check if head is equal to null. Head is not equal to null. That means this is definitely not the first node. This is not the first node. So it's the last node. We are keeping track of last node with the help of pointer node. So what we are going to do next is this pointer node dot next is this one. Node dot next is this one. We are going to, so node dot next, we are going to change this to, and we'll make this pointer point to p. So we are going to create a new pointer. We are going to change this. So node dot next will become p. Until now, node dot next was null. Node dot next was null. So it will become p. So it will store the address of p now. Instead of storing null, it is going to store the address of p. And what is the address of p? Address of p is 300. So this is going to store 300. So as soon as I make write 300 here, this list, this node is has become the part of the linked list. Okay. Now what is your next current node? Again, I am going to do the same thing. Node is equal to, after changing the pointer, I'll do this. Now node will not be pointing here, but node will be pointing to the last node again. So node will not be pointing here. Node will be pointing to the last node again to this pointer. Fine. So this way we are inserting an element, and every time we are this with node equal to p, we are going to implement this. Okay. So this is a simple creation of linked list. Let us see one more insertion. Let us say that now we'll see the entire program. The first possibility is, let us create P. Let us create P. Okay. Uh, then scan the data of P. Now P will be pointing here. P will not be pointing to this particular node anymore. So P will be pointing to this. Create P, create its data. Let us say that it is 30. Its pointer field will become null. Its pointer field will become null. And now just check out if head is equal to null. No, head is 200. Head is not null, so this possibility will not work. The else part will work, where node dot next. What is node? Node is the pointer to the current last node. Okay, previously existing last node in the list. Okay, so node dot next, this field is big. Let us say that this is stored at 400. Okay, so this field becomes 400. So if this becomes 400, ultimately what we are doing, we are creating this link. Okay, so this is done. This new node is also inserted in the list, and node will now point to this. This will be the current node. Fine. So this way, head is pointing to the first node, node is pointing to the last node, and 20, node 20 or node which contains data 20 is the um, is the node with the in the list, inside a list, or in between, somewhere in the list. Okay, so this way we can create a linked list. In few notions you can or in few diagrams you can very easily see the linked list will be drawn in this way. This will be the start. It will say it as start head node or something like this. Okay, I just want to inform you that while drawing the linked list, you take care that you are starting the arrow from this position and ending at just beginning of the node. Okay, you don't put it inside this node, but you start from the point field while drawing it, because it shows that this particular portion of the node is storing the address of this whole node. Okay, so this way you can draw, and let us say that is 10, 20, 30, and in some cases this will be null will be shown this way. Okay, so few diagrams show this way, or you can write null here. This most of the books are drawing the linked list in this way. So you are supposed to, in this way you are supposed to create a linked list. Fine. So one by one you can insert the element at the end. So creation of a linked list is very similar to a to creation of a or insertion at the end. So after this lecture, I want you to write a program, modify this program to insert 5 elements in the list. So just you need to apply a for loop and try to insert all of them and try to display a linked list. Okay, at the end you just apply a for loop and um, go on displaying that linked list. So try a display module for this. Fine. So the same program, modify a bit. You just need to put a for loop here. All the things will work that way, and just write us one more for routine for displaying it. Okay. At that time you'll start from head, and you'll scan the elements one by one by proceeding from node dot next to node dot next is equal to node. So that way you'll proceed till you get node dot next is equal to null. you try a display routine for this and submit it as an assignment by tomorrow 6 o'clock. Again, I am repeating, whatever may be the due date, you are supposed to submit it by tomorrow 6 o'clock. Okay. So this is an assignment, or this is all from my side today. In tomorrow's lecture, we will see that how to insert a node at the beginning, or probably in between somewhere. Fine. So I'll stop here today, and remember that you are supposed to complete the assignment. So in that assignment, you are going to write a display routine also, and you do it for minimum 5 elements. You can go for 10, 15, whatever number of elements you want to go for. Okay. And while displaying, you make use of arrowhead. That means your presentation should be like 10 arrow, 20 arrow, 30. That kind of list must be uh, printed. Okay. Thank you very much.